So let's get started. So thank you all for joining our session. Thanks, Gerard, for the introduction and the awesome headstand. So today, Dominic and I want to talk about RxJS patterns. And the reason we want to give this talk is, well, when we started using RxJS, Dominic and I both love RxJS, but when we started using it, it was super hard. RxJS has a few downsides, and one of them is that it has a very steep learning curve. It almost feels like climbing El Capitan, and I haven't done it yet, but I assume it's not that easy. So what we noticed when we were using projects that were using RxJS is that we started to use these patterns over and over again. And that's what we want to discuss in our talk today. But not only that, we also want to give you a way to reason about your RxJS code, like how to think in RxJS code. Combined the patterns with the thinking reactive, that's what we want to talk about today. So a little bit about ourselves first. So I'm Kwinten. I'm a freelance front-end architect from Belgium. I co-founded a company called Strongbrew, and I'm also a meetup organizer.
And I'm Dominic. I'm a trainer at Thorem. I'm a freelancer. I work at StackBits. I'm a software engineer there. Who knows StackBits? Yes. It's an online IDE to build web applications, and it's pretty awesome. So definitely check that out. Well, something else I want to talk about is an open source project that Kwinten and I created, and it's called the Aggregator checklist. It's a curated list that you can use, and it's a list of best practices that we think every application should follow. And it's open source, as I said, so if you feel like contributing, we would really appreciate that. Okay, so let's talk a little bit about programming before we talk about the good stuff, so that we're all on the same page. Now, reactive programming is programming with asynchronous data streams. And those data streams are often observables. But before we talk about observables, let's first talk about something that we all know, and that is arrays. An array is a data structure, right? And it holds some values. How do we get these values? Well, we pull them out, so it's pull-based. We also have operators, methods defined on an array, and we can use them to modify the array and its items. Now, how does that relate to observables? Well, if you think about it, an observable is pretty much a list, an asynchronous set of values, right? But these values are called events and are delivered over time. Now, but the biggest difference between observables and arrays is that observables are push-based. So these values, these events are being pushed to us rather us pulling them out, right? We also have operators, and we can use them. I like to think about operators as modifiers, so we can use them to do modifications as the values come down the pipe. But the cool thing is that these operators are pretty efficient because we don't have the garbage collection overhead. So with arrays, the methods on an array, we have to create, or we're creating with every method, we would create these intermediate arrays. So that's pretty cool. And looking at the anatomy of an observable, we both like to think about an observable as a box which has a producer function inside. And this producer function is called whenever we subscribe. And that's the lazy part. So subscribing means executing the producer function, producing values, and then sending them to the observer. And the observer is the one that is actually listening. But what I want you to remember from this is that observables are push-based and they're lazy, okay? But this is not the topic of our talk, so that's patterns. Kwinten, can you tell us a little bit about patterns?
Yeah, obviously. So we have patterns, and to kind of go to RxJS patterns, let's first work to a common definition of what is a pattern. So in software design or engineering, a software design pattern is a general reusable solution to a commonly occurring problem within the given context in software design. So what does that mean? Well, basically, when you have problems with the same characteristics and you always solve them in the same way, that's a pattern. So let's define some levels of patterns in the context of this talk. So this is not defined, this is something that we came up with. And you could say that we have 3 levels. So the first level is an operator, an RxJS operator. This is a super common scenario that happens in almost any application, and that's why it's put inside of an operator like in the RxJS code. On top of that, we have patterns. And these are the patterns that we're going to talk about. These are like small building blocks, which are still quite general use case. You can use them often in your own code, but they're not general use case enough to put them in the source code. And on top of that, you could say that we have recipes. If we combine multiple patterns together, then you could say that we get a recipe. And we'll also show you a recipe at the end of the talk. What we could also do is whenever we have our own pattern, we can transform that into an operator, which is also something we'll tackle. So let's go to patterns by example, because this is all very abstract, but let's see how we can create a somewhat real-life application and show you some of these patterns. And Dominic and I both have like a weird kind of humor. So what we're going to build, and this is something you could get from a designer, we are going to build a jokes application. And we're going to use Chuck Norris jokes, but not only Chuck Norris jokes, but also in the context of programming. So one of them, for example, is Chuck Norris can do infinite loops in 4 seconds. I mean, that's at least a little funny, I hope. Otherwise, we're kind of screwed.
I think it's funny.
It's a little funny, right?
A little bit.
OK. So I take this design that I get from a designer, and I go to my manager, and I am super lucky today because my manager is Michael Scott from The Office. That's an awesome manager to have. So I ask him, so what do you want me to do? And he started by saying, OK, yeah, well, we have this list of jokes, and maybe you should cache it, and update it every 10 seconds, and blah, 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 blah. So he blurts out a lot of requirements, and it's super unclear what I need to do with this. Like, how do I think about this? Like, you know what this makes me feel like sometimes? Whoops.
You closed it.
Oh, it crashed.
Thank you.
See, that's what happens when you give talks with me. OK, you know what it makes me feel like? Crashing the application, right?
Yeah.
OK. Makes me feel like punching a hole in the wall, right? So, pun totally gone. So, Dominic, can you teach us a little bit, like, how can we think about this?
Oh, yeah, definitely. So, having this wall of text at least makes me feel very overwhelmed. I don't know where I should start. I just see this wall of text, and it's a bunch of characters, and I don't really know what to do. And we would recommend a approach, way of thinking or paradigm that is called divide and conquer. Now, what does that mean? Well, divide and conquer means that we have a problem, or in general, it's an approach to find an optimal solution to a problem. So we would start with a problem, right? But this problem is similar to the wall of text that we have, and it's pretty difficult to solve all at once. So the idea is to break up this problem into smaller subproblems. And we keep on doing that until these subproblems are easy enough to be solved on their own. And having these subproblems, we can then start to find solutions to these subproblems. And once we have those, the next logical step would be to take those solutions to the subproblems and recombine them to get a solution to the original problem. And that is what a divide and conquer approach is all about. And this is a pretty structured approach, and in my opinion, it's a very good way to approach, well, to find solutions to conceptually difficult problems. And we would always recommend to follow a very similar approach, not only to translate your requirements into code, but also to apply this to your own code. If you have a problem, then think about that, divide it up, split it up, right? And then solve these smaller parts and then bring them back together. So this is Dwight Schrute. He's from The Office. He's, well, a pretty weird dude, I would say. But he has a couple of really cool tips for us. And one of his first tip is, whenever you have a difficult situation, split it up, fix the small parts, and then reassemble everything back together. So think divide and conquer. OK, so let's take a look at our wall of text. Still, I'm pretty overwhelmed, but I feel pretty confident now having the divide and conquer approach. So looking at this closely enough, I can see a couple of sub-requirements, sub-problems. And those are not all of them, but you get the idea. So now having these sub-problems, which I find easy enough to solve on their own, I can just start with my first requirement. And my first requirement would be the list of jokes should be updated every 5 seconds. That was easy. I have it. And it feels like I could do this, but still it's not very obvious to me how I can translate this, the written requirement, into code. How about, what if we had like an approach for this? Can you shed some light on this?
Well, I think the light's already pretty good, but I can explain it if you want. So,
thank
you. Like Andre talked this morning on how to think. Well, we're going to try to teach you how to think reactively. So we did this by like analyzing the patterns and matching them to requirements, and we kind of came up with something that we call pattern detection that should help you translate written requirements into RxJS code. So how does that work? Well, if you have a requirement, you need to find the what, the when, and the how.
What?
Easy, right?
No, not easy to me. Can you elaborate?
Well, yes, I can. So what is the what? Well, a requirement is always something you work towards too. So you need to have a result. And the result is basically the what. And getting into that reactive mindset, we're always going to try to make sure that our result is a stream. Like we should think in observables, we should think in streams. So our result is a stream. Then we also have the when. The when is pretty easy, right? Every time you have a requirement, it almost always starts with, yeah, if this happens, I want to do this. Well, if this happens, that's the when, that's our trigger. And again, it's the same thing. Thinking reactive, our trigger needs to be a stream. And if we don't have a stream, then we're going to create one. And the how is always a little bit implicit. So the how is basically how do we get from this trigger to this result. And to do that, we need to apply a pattern. And that's what we're going to talk about. So another truth tip, always try to make sure that you have a trigger and a result, and they should all be streams. And if your trigger is not a stream, then we're going to create one. So can you try to apply this way of thinking to our requirements?
I can try. I listen to you, and I can take a stab at this. So if I look at this first requirement, it says the list of jokes should be updated every 5 seconds. So you said I have to identify the what, when, and how. So the result, trigger, and basically the pattern. How do I get there? So I would say the what in this case would be, well, what do I want? I want a list of jokes, right? So that's our result. That's something where I want to end up. And then, so that would be our cached list of jokes, because they should be cached. Now the when, well, I think it's also in the requirement. So it says every 5 seconds. So that would be my trigger, no?
Exactly.
OK, so how do I have to do that? Well, think about it. Where do I get the data from? Probably via an HTTP call. So I want to fire or send that HTTP call every 5 seconds. So I make that backend call every 5 seconds. And that would be the how here. As Kwinten said, it's not always super obvious, and it's pretty implicit sometimes. But just try to think about the what, when, and how here. OK, so I think we could try this, but before we do that, this is our application from an architectural point of view. We have on the UI side, we have 2 components, not too fancy, and then we also have 2 services, just so that we have a common ground for you to follow along when we live code. OK, so
let's do this.
Let's do this. So I'm going to open up my code editor, and I will go to the joke service, because that's where my cache lives. And all of that is already implemented. But we want to implement the first requirement. And the first requirement here is, so what do I have? I make a backend call, so I get the data, then I map it, and I have my share replay, which does the caching. That's nice. So I have to update this particular thing every 5 seconds. But where do I get the trigger from? You said it has to be a stream.
Yeah,
what do I have
it has to be a stream. Like if you would say, I want to do something every 5 seconds, your first ID might be, I'm going to use set interval, right? But that's not what we want. We want a stream. And luckily, RxJS has a lot of creational operators. So we can use, and this is what Dominic typed out here, we can use the timer operator from RxJS to create a stream that will emit an event every 5 seconds. And when that event happens, we can react to it. And because our triggers are a stream, we can actually start using operators to chain that together. So what Dominic is doing now, he's using the timer stream that we have, and then he's using exhaust map to basically resubscribe to the HTTP call over and over again. Because remember, observables are lazy, so if we resubscribe, we re-execute them. And this should work, right?
Well, it kind of complains here, map construct. Oh, I knew I would get this. Wait a minute.
So in this use case, we're actually using exhaust map. There are different flattening operators, but we're using exhaust map because that's like, for this use case, the best one. And you can see that it actually works,
well,
right?
It works. My ID was complaining and yelling at me, even though there's no error. Well, let's just ignore that for a second. So as we can see, I just open up the network tab, and we can see the polling works as expected. We're polling new data every 5 seconds. And Kwinten, can you read one of the jokes again?
Yeah, I'm going to read it. Oh, no. Oh, it was gone. What was that?
That sucks.
Like, if I think about it, I couldn't consume it as fast as it was produced.
So we heard about
Did we hear something about
it reminds me of actually back pressure.
Oh, right.
Isn't that back pressuring?
That's back pressure.
So we learned about back pressuring, right? I can't read it as fast as these values are being produced, so we need some kind of strategy to deal with this back pressure. And that's also something that we're going to implement. So let's go back to the slides. Now, our talk is about patterns. What is the pattern that we just used? And we try to formalize this into these patterns. And the first pattern is the repeater pattern. So whenever you have some work that needs to be executed n times, then you would use this repeater. And the structure is always the same. These look very simple, but these are very reoccurring in your application. So they come up all the time. So you have a trigger, you have some kind of flattening operator, and then you want to resubscribe to the work and execute that work whenever the trigger fires a new value.
OK, let's go to the next requirement. Oh, totally forgot Shroot.
Shroot's tip.
Shroot's tip.
And Shroot's tip is the pattern detection, which is always translate your written requirement into the what, when, and how. All right, so let's take a look at our second requirement. And the second requirement would be, well, it sucks that the data is constantly updated in a UI, right? That's back pressuring. We can't read it as fast as the values are being produced. So what if the user has to manually request an update? So we still update the data on the service, but the user has to request it on the UI side. So what would be the when and trigger and the how here?
Well, what do we want? We have a joke stream on the screen. So we only want that joke stream to get like the latest value when the user clicks. So I already said both of them, like the joke stream. And when do we want that? Well, when the user clicks. So how are we going to do that? Well, Jay taught us some techniques to handle back pressure. I think we can use dropping here. Like we only get the latest version whenever the user clicks the button, and the other ones we just discard. So seems easy enough. Let's try to implement it.
Let's try to implement this. All right, so we want to, so the user should click on a button. So that's probably on the UI side. So I'm going to go to the joke list component. And what I have here, and I first want to take a look at the template so that we all understand what's happening here. So I have a button inside my template, and I'm listening for this click event. And, well, I have some kind of update stream, and I call next on it. What is that?
Well, again, triggers should be streams. And unfortunately, right now, today, it's not possible to create a stream from an Angular file event. So what do? Well, if we go to the component, we use a subject. And that subject, what is a subject? Well, it's an observable where you can produce your own values. So we're basically leveraging a subject to create a stream from our event. There are also operators you can use in RxJS, but unfortunately, they're not really usable here. So now that we know when the user updates, we can actually, when the user clicks the button, we have that update stream. We can get the latest version, right?
Exactly, and that's what I just did. So whenever the user clicks on that button, that's what the subject is used for. I take the latest version, so it's kind of lazy. We're kind of enriching a stream lazily. So I take the latest version when my update stream triggers, and then I just simply map it, and that's what the enriching part is. And then here we just simply merge it with some initial data, otherwise we don't see it until our backend actually, or our polling kicks in. So let's see this in action. All right, so let's wait. So it's not updated.
Can I read one now?
There was a polling.
Okay, a diff between your code and Chuck Norris is infinite.
So there's definitely enough time. So yeah, it works. The UI is not updated. We kind of tackled the back pressuring. I click the button, and as you can see, we get the latest version. So this is a very, very common pattern. I can keep on clicking, and well, it only updates when there's a next polling tick.
Well, I see something that annoys you. You're like a pixel perfect designer. I see an update button when there shouldn't be an update button.
No.
Maybe we should fix that next.
Let's fix that. But before we do that, let's talk again about the pattern. The pattern that we just used is something that we call the enricher. It has the following structure. There's a trigger. We have very often the with latest from, and then we use a map to enrich a stream. Okay, so that's what we call the enricher. Okay, so
next requirement. So if an update is available, the user should see a notification to update the list of jokes. And we only want to show it when there is an update, right? So yeah. Define the what, when, and how.
As you can see, this is very, very repetitive. But we also learned from Andre that our brain is a muscle. So we have to train it. So we're just going to repeat this process so that it actually sticks. So the what here is a show notification stream, maybe. And I would say that shows and hides notifications. And then the when would be maybe whenever there's an update available, right?
Makes sense. But do we have everything then? Like, when are we going to hide the notification?
When the user clicks on a button. So it seems that we actually have two triggers, which are kind of hidden here. So it's not always that explicit. And the how would be, well, we create two triggers, one for showing, one for hiding a notification, and then, well, it's all about recombining these streams, these intermediate streams that we have. Okay, so I would say we're going to implement this now. And this is also inside my joke list component. So what I'm going to do is we have two triggers, so I have to create two streams. So I'm going to say const show, and then what is my trigger again for show?
Well, the trigger is basically whenever we get a value from the source joke. So the source jokes is our cache stream, so whenever that one has a value, then we want to show the notification, I guess.
So in this case, whenever, because we want to show something that would translate into a Boolean value, so what I can do is I just simply map it to a positive, right? In this case, true. I want to show a notification when there's an update available. And the next thing I'm going to do is I'm going to create a hide stream. In this case, my trigger would be, well, I can use the subject, right?
Yeah, we already have a stream like the update stream that fires whenever the user clicks the button. So when he clicks the button, we know he got the last value, so we probably want to hide it.
And then last but not least, we have to recombine those two streams. So I'm just going to simply merge my show stream and my hide stream. Does that look familiar? Well, I created two streams. You can think of this as also applying the divide and conquer approach to my code, right? Just splitting it up into smaller problems, show and hide, solving those, and then bringing that back together. OK, so let's take a look. I'm going to reload the page.
Oh, don't forget
there's something
to update the template.
I forgot, which is the template. I actually have to enable this and comment this out. So we've got hopefully a notification. We don't. What? Oh, I did not save this.
Oh, saving.
My bad. Ooh, OK. It seems that the notifications work. Let's give it 5 more seconds. Let's update this. This seems to work. Okay. Maybe 5 more seconds. Let's hope for another notification.
Yeah, that works. Oops. But there was an issue, right?
I think when I reloaded the page, we got that notification right away.
Yeah, I think we made a mistake there.
I think so,
too. I think the mistake we made was with our trigger. So we applied the pattern, but our trigger was actually wrong because we don't want to show the notification when we get something from the source jokes. We want to show it when we get it a second time from the source jokes, right? Because the first time we're just going to render it on screen, and only for the second time we want to tell them there's a new update available. So what are you doing, Dominic?
Well, I'm just refining my show trigger, and I'm just going to skip the first value. That's pretty simple, I would say. All right, so let's see if it works. Reloading the application, no initial notification.
That
seems to work. And this is a pretty nice UX pattern, if you ask me. Oh. We notify the user that there's new data, and it's a pretty neat way of solving that back pressure situation. OK, so what is the pattern that we just used?
Well, what we used is what we call the group aggregator. And when can you use this? Well, when your result stream, what you're working towards to, is an observable of type Boolean, what you could do is you could create a stream which combines all of the positive values, a stream that combines all of the negative values, and then combine them together. Pretty easy, I guess.
Yep. So next, on to the next requirement, and we're almost there. And the next requirement would be, what is an application without settings, right? And let's build some settings that the user can actually update in the UI via a dialog. What would be the what, when, and how here?
Well, the what we are working towards. Well, we have some settings that we need to manage. So I think we need to create a settings object. But again, in that reactive mindset, we always want states to live inside of streams. So I'm going to work towards a setting stream that encapsulates that state.
So it's not a good idea to have variables outside of the stream that keep the state?
No, exactly, because a lot of sources for bugs are when a certain variable on a class is in an unpredicted state. And if you encapsulate that inside of an observable, then it can only be updated by changing something via the trigger. And the trigger in our case is when the user changes one of the settings. So because that's the only way to change it, it becomes very deterministic and predictable. So how are we going to do this? Well, we need to manage that state, and luckily we have RxJS, which has quite a lot of operators to do so. So maybe you can implement it.
Let's try to implement this. Before we do that, we have another Shroot's tip. Shroot says state should always be managed within the stream, just to make it more predictable and less unexpected behavior. OK, so let's implement this. I'm going to go here. So that's going to be inside my settings service. So I want to manage state, and it has to be within the stream. I don't want to have any state outside of the stream. So for the trigger, well, I have a function. That's probably a function call, right? So from the dialog, I would call a function to the service, and then that does something. But you said the trigger should always be a stream. What can I do here?
Well, trigger should be a stream. We have a function call. How do we transform a function call to a stream? Well, in this case, we can use a behavior subject. So why don't we use a regular subject but a behavior subject? Well, the behavior subject gives us that initial value. So you can see that we pass to the constructor the initial state, which just says that we are enabling polling, showing notification, and defining the polling interval. And then based on that stream, we can actually use the scan operator, which Dominic is typing out, to manage that state.
Exactly. So that's what I'm doing. I'm subscribing so that we can actually test this out. Let's see. Let me open up the console. Zoom in a little bit. We can see our initial state from the behavior subject, and it seems to work. Now we have this little gear up here, and I can change one of these settings. Let's say I disable the polling, and we see it is managed, but within the pipeline, and always try to do exactly that. Don't have any external state. Cool. So the pattern that we just used is the state manager. So whenever you have to reactively manage state, this is a very, very simple approach of state management, but it's very helpful already. It gets you very far. So you can just use a trigger, then the scan operator to keep the state and accumulate it, encapsulate it within the observable pipeline. So truth tip number 5 is use the state manager pattern for a minimalistic alternative to state management libraries like Redux. You can get pretty far.
OK, so next, we have settings, but we're not doing anything with settings, which doesn't really make sense. So let's use them, and let's make sure that our user can toggle the notifications and the polling. So, Dominic.
So the one in this case would probably the cached jokes, because polling has to do with my cached jokes, and I probably want to do something with that. And maybe a show notification stream, because I want to show and hide notifications and disable that. So that will be my what in this case. The trigger, well, whenever one of these settings have changed, that's the toggle, so that would be my trigger. And the how in this case, well, it's conditionally stopping and restarting work, right? If something has changed, maybe I want to stop it first, and then I want to restart it again. So that's what we want to do here. OK. So, and we're going to do that maybe only for the polling, because we don't have that much time. So I'm just going to go to, where do I have to go? To my jokes service, and what I will do is, well, so I need a trigger that is a stream. I know that my settings service exposes a stream, so I can just use that, right?
Exactly. So we have the settings stream, which is going to fire whenever the settings changed. So we already have that trigger. And what's really interesting here, at least in my opinion, is that our service is exposing a stream. And using streams in a layered architecture, if you use them as the boundaries between different layers, like from services to components, that actually makes a lot of sense, because you have that common boundary, and you can actually start replacing layers with other layers, as long as they expose the same observables. So Dominic now is using the settings stream. We're taking out the polling enabled. Then we're checking, did it change, like distinct until change, did the value actually change? And if that happened, then we're going to do one thing. So we're going to switch map over that, and then we are going to check, like, is our polling enabled? So if polling enabled, then we want to do some work, like do the polling. And otherwise, well, otherwise we actually don't want to do anything, right?
Oh, we just return a stream that completes right away, and you can do that with empty.
You could have a situation where you do want to do something otherwise, like when the condition is false, you do want to do something, but in our case, it's not really necessary.
So let's see if I got this right. This dot jokes, definitely assign this back, and then
import the empty, maybe.
Maybe import empty. Is empty not imported? So let's see.
That probably works.
Oh.
Let's hope. Oh.
No, that's live coding. What did I do? Well, I have a branch for this.
We prepared, yeah.
So we definitely prepared if something goes wrong. Well, I just typed it, and it did not work out very well. So let's not save that, open up my joke service. And this is pretty much what I do with a bunch of more features, but you get the idea. So we did this map, distinct until change, and the switch map with a conditional inside. So that's what we have. Now let's try and see if that works. Let me open up the network tab, and we can see that the polling works. Let me stop it. We shouldn't see any more backend calls. Seems to work.
Seems to work.
Oops.
Oh, new backend call.
New backend call, and it seems to work.
Polling? Oh, another one.
Works.
It seems like it works.
Nice.
So what's the pattern here?
So the pattern is something that we call the work decider, and you have a trigger and some kind of flattening operator. That's the general structure of this pattern. And then you always have, well, a conditional inside. So whenever you have to stop and restart something, it will be this. Well, actually, the stopping and restarting comes from the switch map that we just used. But yeah, this is something, well, if you want to do something conditionally based on some trigger, you would use the work decider. Okay, so truth tip number 6, use observables as the boundaries between services and components. Because in the layout architecture, Kwinten just explained that, we want to have streams like as boundaries, which is a pretty good thing. So our last requirement for today seems pretty complex. So if fetching of the list fails, we want to retry it. And we only want to, so this means that if we're offline, we only want to retry when we come back online. Otherwise, we want to retry every second with a max of 5. Well, that's pretty complex, I would say. How about we just apply a divide and conquer approach again, and we just break it up? So remember truth tip number 1, divide and conquer, split it up, right? So our first sub-requirement would be if fetching the list fails, we want to retry it. This seems pretty simple with RxJS.
This seems pretty simple, and I think there's also a pattern inside of an operator for that. I think we could use retry when here.
Yeah, exactly. So let's just go on to the next sub-requirement, and that would be, well, if we're offline, we only want to retry if we come back online. Otherwise, retry with 1 second with a max of 5. Whoa, okay. What is the what, when, and how here?
Well, I think I already see something coming back again. So, like, what is, well, we want to go to our cache joke stream. We want to retry that one. And the when is, well, whenever we have an error, we need to do something. That's our when here. And, well, if we think about it, the how is basically a conditional again. So we have a stream, which is a trigger, and then we conditionally, if it failed because we were offline, we only want to do it when we're online, and otherwise we want to retry it a few times. So that seems like...
Didn't we talk about something conditional already?
Yeah.
The work decider, maybe?
I think it's the same thing.
Let's just take a look at the code. We're not going to implement this just to show you how this looks like. I'm just going to check out branch 6 here. Let me go to the code. And what we have here is, as you can see, so on the polling stream itself, let me make this a little bit more visible. We have the retry when, so whenever there's an error, we want to retry something conditionally. That's why we use retry when. That's a very less general use case pattern. And then we get an error stream. And doesn't that look very familiar already? Like the switch map with the conditional inside, we have some work and some other work. Well, that's pretty much the work decider. It's just... But the combination of retry when and the work decider, like multiple patterns, is something that we call recipe. Okay.
Let's see if it works.
Let's see if it works. That's a good point. So let me make this here, and maybe I can go offline, which is, I think, this thing. Okay, the call fails. We're not retrying anything because it's conditional. Yeah. And let me go back online.
Oh, and we have a call.
And it seems to work.
Seems to work.
Cool. Let's go back. Yeah, someone's excited. That's nice. All right, so, well, this is the pattern. We call it error decider. It's actually not a pattern. It's a recipe, right? It's a combination of multiple patterns, and it's just reoccurring. Okay.
Yeah, so now, last step, we're not going to code this, but this is kind of like a tip. So whenever you have a pattern in your own code base that you use over and over again, and sometimes, for example, if you use the bounce time in there, there's like a certain number in there, transform that like entire structure into an operator, because this allows us to have like a consistent behavior throughout our entire application. Don't re-implement this. Transform this into an operator, and this is actually Dwight's last tip. If you have your own pattern in your own code base, in your team, in your application, transform it into an operator to have consistency in your entire app. So, key takeaways.
Well, try to think about divide and conquer. Use divide and conquer to split a more complex problem into sub-problems, solve those, and then reassemble everything back together. Divide and conquer really, really helps us, at least.
Exactly. Remember some of the patterns we showed, but also like how to think in patterns. Use the pattern detection. What we had in terms of requirements was very, very easy. The patterns were very, very low level, but we implemented something, I would say, a little bit complex in a really short amount of time.
And if you have patterns that reoccur over and over again, try to like refactor this into custom operators. Okay, but most importantly, think reactive.
Exactly. Triggers should be streams, results should be streams, state should be managed inside of a stream. I think stream is kind of the key word here, right?
Stream is definitely the key word here. All right, so thank you so much. We're going to tweet the link to the slides and the code on Twitter. Yeah, thank you so much for listening and enjoy the rest of the conference.